Hi friends, in today's video we are going to discuss in problems of exercise 1.4. Okay, so in exercise 1.4 is totally of proving the numbers whether they are rational or irrational. Okay, so now first bit, all these questions they given us to find whether the numbers are irrational or not. Okay, prove that this number is irrational, similarly prove that this number is irrational, this is irrational, this is all we need to prove that these numbers are irrational. Okay, first one you see, first one they given 1 by root 2. Okay, 1 by root 2, let us assume that let us assume that this 1 by 2, 1 by root 2 is a rational number. Okay, let us assume 1 by root 2 is a rational number. If 1 by root 2 is a rational number, we can write it is equal to a by b or p by q, right? It is a rational number, no? So simply we can write like this. So if you cross multiply, what you will get? B is equals to root 2a, right? B is equals to root 2a, and from here b by a is equal to root 2, right? B by a is equal to root 2. Here b by a is what? It is a rational number. We already know it is a rational number. Okay, and prime factors, that means cofactors between them, okay, is equal to 1. Okay, these are prime numbers. Okay, and b and a are is equal to rational number. B by a is equal to rational number, but we know that we know root 2 is irrational, right? Root 2 is irrational. We know the fact, fact that root 2 is irrational number. If root 2 is irrational, b by a is rational, can rational number be equal to irrational number? Okay, can this be possible? No, right? Rational number cannot be equal to irrational number. So b by a cannot be equal to root 2. So therefore our assumption is wrong. What we have assumed? We have assumed that 1 by root 2 is a rational number. That is wrong. Then what is 1 by root 2? So therefore our assumption is wrong. Okay, our assumption is wrong. So therefore 1 by root 2 is a irrational number. Okay, 1 by root 2 is a irrational number. Okay, so the same process you are going to follow for each and every question. Okay, next question is what they are given? Root 3 plus root 5 they are given. Okay, root 3 plus root 5. See how we are going to calculate root 3 plus root 5. Here also same thing. First we will assume this root 3 plus root 5 as rational number. Okay, we will assume if this is a rational number, then it is equal to a by b or not, right? So send any one number that side. Root 3 is equal to a by b minus root 5. Okay, you apply squaring on both sides for this. If you apply squaring on both sides, what you will get? Root 3 whole square is equals to a by root 5 whole square, right? So this one square and root will cancel, you will get 3. This one a minus b whole square. A minus b whole square formula is what? A square, okay, plus b square minus 2ab. Okay, this is the formula. So 3 is equals to, this one will become a square by b square is equal to root 5 whole square means 5 only, no? 5. This one 2 root 5 a by b. Okay, 2 root 5 a by b. Now can we transfer all the rational numbers one side? Transfer. You bring this minus 2 root 5 this side and plus 3 that side. Okay, what it will become? This will become 2 root 5 a by b. I am bringing this 2 root 5 a by b this side, so that it will become plus. Here minus is there, so it will become plus. That is equal to a square by b square plus 5. If this 3 comes this side, it will become minus 3, right? 5 minus 3, how much? 2. Okay, next step. So you bring this to this side. Root 5 into a by b is equals to a square by b square plus 2. If this 2 is multiplying here, it will become division, right? So 1 by 2. I am sending this to this side. Okay, so here root 5, you send this b, a by b this side, it will become b by a. That means b is getting division here. If this goes this side, it will become multiplication. So that's why b by a, it will become just reverse. B by a into 1 by 2 a square by b square plus 2. Okay, now you see this a and b are integers here. integers means we can take minus infinity to plus infinity, any one value, rational number. So if you take a value 1 and b value 2, you will get rational number or irrational number this side. Always you will get rational number only this side. But we know the fact that root 5 is irrational number. So now again same statement, root 5 can be equal to this rational number? No, because this is irrational number, we already know, and the right hand side we are getting rational number. So irrational number can't be equal to rational number, so therefore our assumption is wrong. Okay, this contradicts the fact. Okay, our assumption is wrong. If our assumption is wrong, what we have assumed? We have assumed that root 3 plus root 5 is a rational number. That is wrong. Then what is correct? Root 3 plus root 5 is a irrational number. So therefore you have to write all these steps. Okay, you have to write here irrational number cannot be equal to rational number, therefore our assumption is wrong. That is root 3 plus root 5 is not equal to a by b, so therefore root 3 plus root 5 is irrational. This is what you write. Okay, similarly you see this question, third one. So third one also similar. So first you will assume 6 plus root 2 is equal to a by b. You will assume it as it is equal to rational number. Again same story. So you send this side, root 2 is equals to a by b minus 6 you write. Okay, root 2 is equal to, I am sending this side, a by b minus 6. Here a and b are integers, minus 6. Again you will get only rational number this side. You know that this is an irrational number. Okay, again same statement, irrational number can't be equal to rational number, therefore our assumption is wrong. Okay, our assumption is wrong, therefore 6 plus root 2 is irrational. Clear? So similarly root 5, for root 5 how do you have to prove root 5? Root 5 this is somewhat different, so try to look. Okay, so first you assume that root 5 is equal to a by b. I am assuming that root 5 is a rational number. Okay, first you assume root 5 is a rational number. If root 5 is a rational number, again same story, just like this. Okay, if root 5 is a rational number, we already know that root 5, okay, we already know what root 5 is a irrational cannot be equal to rational number, so that's why our assumption is wrong, root 5 is irrational. You can write directly, but when they give for short answer you have to expand. Okay, how? So listen here, first we are assuming it root 5 is equal to a by b, that is irrational number. Okay, then from here you just cross multiply, what you will get, b into root 5 is equal to a. Okay, if you do squaring on both sides, what you will get? If you do squaring on both sides, b square into 5, that means 5b square is equals to a square, right? That means from this statement we came to know that 5 divides a square. Okay, 5 divides a square. If 5 divides a square, 5 also divides a. This we already know from theorem, right? 5 also divides a. That means we can write like this. Okay, 5 also divides a means, right, a is equals to 5c, right? We can write like this. Okay, a equal to 5c, right? Now already what we know, a, if you do squaring on both sides for this, what you will get, a square is equals to 25c square, right? So a square, what is the a square value? A square value is how much? 5b square. We already know a square value is 5b square. A square place I am writing 5b square, that is equal to 25c square. So from here 5 ones are 5 5s, so b square is equals to 5c square. Okay, b square is equals to 5c square. From this relation what you came to know, that means 5 divides b square, right? 5 divides b square. If 5 divides b square, 5 also divides b or not? 5 also divides b, right? 5 also divides b. Now you listen carefully, 5 divides b, 5 also divides a. From this statement 5 also divides a, right? That means for a and b, we have common factor 5. we have common factor as 5, right? For a and b we have common factor as 5, but as per our rule, okay, but as per our rule here, a and b rational numbers, here a and b should be co-primes or not. Here a comma b are co-primes. We are assumed these are co-primes. Co-primes means what? They should not have any common factor except 1. That means their HCF is equals to 1. A and b are co-primes. Okay, that means they should not have any common factor except 1. But from this what we came to know, a and b have common factor 5. That means our statement is wrong or not? A by b, actually we assumed a by b are co-primes, but co-primes means only common factor should be 1, but we got 5 also common factor. If we are getting common factor, then this a by b is a co-primes? No, right? So a by b are not co-primes. If a by b are not co-primes, then a comma b are not co-primes, then a by b is not a rational number. If a by b is not a rational number, then a by b will be equal to irrational number. So what is a by b? Root 5. So that's why root 5 is irrational. Are you able to understand? So this is the process you have to follow. Okay, so 5 divides a, 5 also divides b, so that's why we have two common factors. Okay, that means a and b are having common factor 5 other than 1. So a and b are not co-primes. So a comma b are not co-primes. Okay, a comma b are not co-primes, therefore our assumption is wrong. Okay, therefore our assumption is wrong. Then what is correct? Therefore root 5 is irrational. This is the process you have to do. If they give only single statement, that means single number, this is the process you have to follow for every question. If they ask for root 2, if they ask for root 3, so same process you have to follow. Okay, this is how you have to follow. If you are getting any doubts for this question, please post me in the comment section, I will give reply. Okay, and this question already you know, just like previous question. 3 plus 2 root 5. First we will assume 3 plus 2 root 5 is equals to p by q. We will assume this number is equal to a rational number, and then 2 root 5 is equals to p minus q by 3. Okay, from here root 5 is equals to 1 by 2 p by q minus 3. Okay, here you see this total is rational number, this is irrational number, so rational number can't be equal to irrational number, so that's why our assumption is wrong. So therefore 3 plus 2 root 5 is irrational. Okay, similarly second bit they are given one question, prove that root p plus root q are irrational. Okay, here also you will do same thing. First you will assume let root p plus root q is rational, that means it is equal to a by b. Okay, root p plus root q equal to rational, it is equal to a by b. And again you will do same thing, you will do squaring on both sides for this. Root p is equals to a by b minus root q. Okay, you will apply squaring on both sides for this. If you apply squaring on both sides, SBS, okay,